Sir, we are good to go. I have started the live stream, so we can start our webinar now. And you can
Very
stop
good.
the recording.
Okay, great. So that meeting host, you do it.
Okay, I'll do it. I'll do that. Sure, sure.
You stop the recording and I'll start.
Sure, sure.
Okay. So Mohan, NACDeC-VI participant, Sayyid Mujahideen, NACDeC-VI participant, you are not listening to what we are saying. We are only requesting you to rename yourselves with your team name. Is it a very difficult job to do? Aditya Gautam, Shivam Chaudhary, Shakti Vail, Mohan. Is it very difficult to do this? Okay. All right, we'll start the presentation now.
Sir, I have made you the host. I think only you can stop the recording because you had started it.
Okay.
Just see if you can stop the recording, not the live streaming.
Yeah, I have just paused the record, stop the recording. Okay.
Great. Now we can begin.
All
All
right.
good.
Good to go. So I'm sure my screen is visible and I'm opening the PowerPoint now. Pranav, please confirm.
Yes, sir. All good. Yes, sir. All good.
Um, Fine, this is okay.
Yes.
So
Yes.
welcome to the second webinar of NACDeC-VII. As you all know, this time we are looking at conceptual design and sizing of a UAV for exploring the atmosphere of Mars, and this UAV needs to be solar powered. So the outline of today's presentation is, or the webinar is, that we will first give a feedback on your IVRs, and then we will give you some idea about what is the way forward and what is the importance of having a formal methodology to carry out the design. We look at the next steps, design framework, what is exactly to be done. And as an example, we will present to you some of the very preliminary results that we got when we tried to explore this domain. These results, which I'm going to show you, are only meant for indicative purposes, and that is why we have hidden the numerical values of the X and Y axis so that you don't get biased by the numbers. So let me start with feedback on the IVRs given by the evaluators. The general feedback we got is that we are disappointed. The presentation style and the PPT that you have made and submitted is not up to the mark that we expect. There are several issues with the quality of audio and video. Many teams, they have made the presentation very text heavy. Too much of text. It seemed like last minute copy paste job. Somehow create a PPT with content and just push it. And many of the students, they were simply reading from the screen. So you have to respect the viewer. The viewer is not illiterate or blind, and therefore, if you show something on the screen, there is no point in reading it. Okay. So for example, if I use the PPT, and if I say audio video quality issues, PPT extremely text heavy, reading from screen, you will be offended because I'm adding no value to what is there on the screen. On the literature review, we also found it very unsatisfactory compared to the time available to you and the team size. We would have expected much more detailed survey of literature. The insights of the teams were not shared. You have reported the content that you downloaded as a clerical person would do without any value addition from your side. You have just said, I found this, I found that, we saw this, we saw that. That is not good. Okay. What is required is what did you learn from the literature and what kind of lessons you have drawn, what kind of ideas you have got. The references to the literature was not written in the proper fashion. There is a formal procedure of giving references, and we have shared, I think, the notes regarding how to do it, but people have not bothered. All these things are going to be very, very important in your next report. Okay, so be very careful. Then, what are the conclusions from your literature review? That is missing. So, as I mentioned, it seemed to be a pure clerical task. So, I don't want to conduct this competition for a bunch of clerks. I want to do it for engineers. And engineers are known to draw lessons from uh, other people's work and make plans for their future. Okay, so I might sound very harsh to you, but the feedback is that we are very unhappy so far with your submission. Okay. Too much attention has been given to topics which are out of scope, which are not really needed to be done. Okay. For example, in the irradiance model, which is required, people are worried about latitude, longitude. Nowhere in the problem statement have we mentioned that you need to design this system for a particular lat long. So you don't have to worry about all those nitty-gritty details. Mission planning from Earth to Mars. Did I mention in the problem statement anywhere that how will you reach Mars? None of your business. That is not the project given to you. You are designing the UAV, not the rocket launching system or the rocket system. So you have been given some constraints in the rocket. Leave that design to the rocket teams. Your job is to design the UAV and not the mission from Earth to the Mars. Then none of the teams apparently had any worthwhile validation of whatever they have done. Okay. Unless you validate what you have done, actually the data that you report is not reliable. The general comment from the committee is that we did not get any wow factor from the most of the submissions. We are not really getting excited about it. People are unclear with the way to proceed with the design, and therefore we wanted to do this webinar. The mission specific questions are not addressed in whatever configurations you identify as promising configurations. On what basis are they promising? Do they address a specific mission requirement? Only then they are promising. Otherwise, they are promising because you like them. So we are not here to choose configurations based on your liking or based on something for which data is available. The configurations are promising when they have features which can address the mission requirements better. Okay. Just for your memory, this is the timeline of the project. Now, the first part is over and already teams have been selected for stage 2. Now, the next important thing is approximately 2 months away, less than 2 months away. Okay, that is the midterm report submission. And we were very liberal. We were very liberal in the IVR evaluation. In normal circumstances, we would have rejected most of the IVRs received, but we were liberal, so we have allowed many IVRs to continue. But we are going to be brutally harsh in the midterm report submission. If we find that the team is not writing the references properly, if they are not doing the work that we need them to do, we are going to be very harsh. So this is the time for you to pull up your socks and to do good quality work and leave enough time for writing the report. What seems to appear from the evaluation is that people are not giving time for report writing or preparation. they are working till the last minute and then they are somehow putting together things. That will not be acceptable in the next one. So the midterm report will ensure that only those teams which have done substantial work will continue and other teams will be asked to discontinue. By mid-March, you should know whether you are in or not. One request I want to give you is that you don't assume that you are rejected or accepted. You continue working because we will need 1 month to do the evaluation maximum, but you don't have to wait. So you assume that you are shortlisted, you submit the midterm report and continue working for 1 more month till you come to know about the status of stage 3. Okay. Now, let us look at the need for a methodology for carrying out the design of the UAV. If you have a methodology, you can approach the problem in a structured and formal fashion. This methodology, it should encompass all your models. It should involve all the things which are needed and that you identify in your initial evaluation. For example, aerodynamics, propulsion, structures. In this particular problem, all these are going to be important. Then you have to identify and assess which are the areas where things can go wrong, which are the critical areas, by finding the sensitivity of various parameters. So the methodology is useful because it can be used for sensitivity analysis. And as you all know, design is basically an iterative process. So you have to improve the design iteratively and refine it as you go. Then if you use a proper scheme or a methodology, then you are able to validate it very easily and also authenticate your numbers. Plus, it's very important from the point of view of project management. It enhances the communication between the teams so that nobody feels left out. Nobody feels that their work is not incorporated. So because of this, we suggest that you develop a design methodology for whatever project, whatever configuration you decide. For example, we did some studies long ago on an airship for exploring on Mars. Now, I'm not saying that you should work on airship. Okay, I'm not saying that, but you can see on the top left, we first came up with a methodology that how will we do it? Okay, you go systematically one by one, one by one, one by one, and then finally uh, you know, converge on the design. So similarly, you have to do a methodology creation first for whatever configuration. And if you are looking at 3 or 4 configurations which are very, very totally different, you will have to make different methodologies with certain things common and certain switches which allow you to explore that particular dimension and come back. So here, for example, we found that if you look at the total free lift on an airship against as the free lift, as the mass increases, the free lift increases almost linearly. This is what we found. So the methodology that you develop is helpful in obtaining such trends to get to know where things can go wrong, because there is a limit on the upper limit on the total mass. So immediately you come to know what is the limit. So these kind of graphs have to be obtained when you use the methodology. Similarly, we also came across in literature a methodology for designing a fixed wing UAV. Okay, where there are 2 kinds of balances. There is an energy balance where energy required is balanced with energy needed. Energy produced, and the mass to be lifted is balanced with the total mass of the system. Okay, on the right hand side top, you can see this is taken directly from a paper. I don't want to go into details right now because I'm not suggesting that you use this methodology only. And then once you use a methodology, for example, this particular work that you are seeing is based on the PhD thesis of Dr. North from ETH Zurich. His thesis is easily available online. Okay, this is the design of a UAV for continuous flight, which is also what you want to do. but his work is, I think, mainly for Earth, and you'll have to adapt it for the Mars environment. So you can see that when you when you make a methodology, you can actually do a study of how does the wingspan change, how does the total mass of the aircraft change as the wingspan changes for various aspect ratio values, and similarly power at the propeller, speed, wing area, solar area ratio, how does it change with wingspan for various aspect ratios. These kind of numbers can be generated by you if you have a proper methodology. Now, the design framework for this problem is very straightforward. You need an energy model, right? And you need a mass model. These are coupled together through aerodynamics and propulsion models. So all of them have to work together. As I said, there will be energy balance. That means energy required should be balanced with the energy available, and mass of the system should balance with the mass that can be carried. Okay. And with that, you will get the final design. Now, in case of a multi-rotor, right? If you are using a multi-rotor, this is the path it will follow, or it will follow this path. This is for investigation of some crevices on Mars. So this was a problem that was investigated. Correct. Similarly, if you are going to look at multi-rotor UAVs, we have done some studies on, how for various types, coaxial helicopter, single disc helicopter, all kinds of configurations. We have done some study that if the payload is 0.93 kg, what is the mass? If there is 2 kg, what is the mass? Similarly, breakdown of the various items should also be investigated. These are the kind of things we want you to study. Okay. Similarly, some results have been presented here as the payload increases, how does the power required change for a quadcopter or a coaxial helicopter? Okay. Similarly, solar panel area variation with payload. Then, if you look at three things here, the endurance, the payload mass, and the total mass, how do they vary with each other at different aspect ratios for an assumed value of solar irradiance, which can then be modified to bring in the actual solar irradiance. Similarly, vehicle mass versus endurance versus payload. So, these kind of studies have to be done. And then you need to get an idea about how much is the power consumed as a function of time and how much is the solar power generated. So we found here, for example, that the solar power generated is too small. It's hardly visible. It's in the bottom, the red line, which is constant. But the power consumed is very high in the initial phase when the UAV climbs up to the altitude of endurance, and then it remains the same, and then for a long time it remains the same, and then again it comes down. And then the other thing that you have to study is stowage, because this whole system has to be folded and carried in an aeroshell. So it's important for you to study in literature what kind of systems have been used, right from the very small Ingenuity, total mass 1.8 kg, up to a large one. So this, I'm repeating what we showed you last time. We are suggesting some softwares that we would recommend, but we are not saying that you should use this only. We are only suggesting. Some of these softwares are commercial, therefore you will have to have licenses to use them. Software like LaTeX, uh, is open source. OpenFOAM, OpenVST, these are all open source softwares. Okay, that's all. We want to open it for queries. In fact, we want to have a bigger discussion rather than my presentation. So I'm going to stop my sharing. Oops.
Good morning, sir. This is Rajat from
One
Team
minute.
Mangal.
Just 1 minute. Yeah, correct.
Yes,
We can start our discussion now.
Yeah, sir. So very good morning, sir. Thanks for your inputs and your guidelines. So coming to the design framework, I think could you please refresh this diagram, the slides you showed there, the energy model and the aerodynamic model, and what are the other models that we need to basically develop, we need to integrate this system.
You don't have to go by what we have done. We have just shown you that you have to investigate various types of configurations. We don't want to bias you by saying that use these systems only. You determine. You determine. I'll just start my video. Sorry, I think my video was off. So you determine as a team which configurations are suitable. Don't go by the configuration that we have studied.
Hmm. Yes, sir.
Okay. But
I,
But what we are suggesting is that when you decide a configuration, you have to carry out, you have to first make a proper methodology for sizing of that particular configuration. And then you have to carry out these kind of what if scenarios and studies. Only then it is designed. Otherwise, I have seen reports where people say, assuming this, assuming that, assuming this, here is a number. But everything is assumed. Everything is assumed. Absolutely no justification is there for anything. That
yes,
is
sir.
what I mean.
So adding to that, could you please uh, tell us the PhD thesis of this work, sir? What is his name for our reference?
Yeah. So I mentioned to you now. I mean, see, this particular recording will be available online. You can watch
Okay,
it
sir.
again and check it. It's a PhD thesis by
Sure.
North. If you want, we can share on the WhatsApp group. But the thing is, this is a competition. You need to
Yeah.
find out yourself. No?
Okay, sir.
Everything cannot be given to you.
Hmm. Yes, sir. Thank you very much.
If we can locate something online, so should you be able to locate.
Yes, sir.
So all the students who are still with their names, please convert it to your team name. Okay, next question or query.
Good morning, sir. I'm from Pond UAV.
Yes,
Sir, can our UAV cover some amount of range as a part of its mission, or is it just the number of sorties?
I have already answered this question, and I will repeat here that your UAV need not climb vertically. It can actually climb at an angle. Okay. So yes, it can cover a large part or a small part of its range in climbing flight.
Thank you, sir.
Is that your question or something else?
Sir, I just want to know that if it is
Correct.
strict.
So we are not insisting on a vertical climb and then
Yes.
horizontal flight, because the aim of this UAV is to actually measure the data in the boundary layer of Mars. So as long as you are traversing the boundary layer, it need not be in vertical mode. You could be slowly climbing and then hitting the top and then slowly coming down. That is also permissible. You just have to go up and down as much as possible.
Sir, is there any limit to the hovering time at 100 meters of altitude?
No, no, there's no need to hover.
Okay, sir.
I'll again repeat. Imagine you are a probe. Your UAV carries a probe which has to traverse in the boundary layer. So the traversing need not be vertical. You have to just keep traversing up and down, up and down, up and down in the boundary layer of Mars.
Yes, sir.
So there's
Thank you.
no need to hover. There's no need to hover. There's no need to go purely vertical and come down purely vertical.
Yes, sir. Thank you for the answer.
Yeah.
Good morning, sir. Can you hear me?
Hmm.
Yeah.
Yeah, I
Sir,
can hear you.
I'm
Go
from
ahead.
the team Flight Forge. So we had a few questions for you. We had proposed several configurations in the stage one of the competition. So do we have to do the sizing methodology for all of the proposed configurations?
No, we are not insisting. We are saying you decide. See, in the initial study, normally we study all kinds of configurations, and then ultimately the team has to zero into maybe 2 or 3 max. That is our advice. Okay, if you zoom into only one and say this is what we will study, and suppose down the line you find it infeasible, then you have to traverse all the way back. So it's a good idea to have 2 or 3. So what would be nice is if a team of 4 students or 3 students, they have their own internal competition. So up to the midterm, we will be happy if you investigate more configurations and then come to some kind of a conclusion that in the next stage we will investigate only these two or only this one. At this stage, do not get hooked to one configuration and focus only on that. This is the exploratory stage. So explore.
Okay, sir. Thank you. Sir, another question. In the problem statement, for the second report, you've explicitly mentioned aerodynamic parameters. Sir, exactly what aerodynamic parameters are you looking for?
This is a UAV, no? So for a UAV, what kind of parameters are considered for aerodynamic design? This is a flying aircraft, no? It is not a balloon. It is not, some other kind of a vehicle. It's an aircraft. So an aircraft, when it flies in an atmosphere, it has aerodynamic forces. So the same as what you have on Earth. You have lift, you have drag, you have moments. So lift coefficient, drag coefficient, moment coefficient. These are the standard aerodynamic coefficients for any flying body. Whether it's a helicopter, whether it's a twin rotor, multi-rotor, whether it is quadcopter, whether it is fixed wing, 2 wings, all of them will have the same. The aerodynamic parameters are the same because there is atmosphere. This is the atmospheric vehicle. This is not a space vehicle.
Okay, sir. Thank you.
Yeah, this project is not about spacecraft design. So don't worry about rockets and all those things. You have to design the UAV, which is a flying body. Yes, Team Safira, please go ahead. You have raised your hand.
Good morning, sir. I'm from Team Safira, and I would like to ask if the dimensions of the payload, like the equipments and all, will be provided.
Not right now. We also don't know. See, this is a live project from ISRO, and there is a lab called as PRL, Physical Research Laboratory. Down the line, we will invite them to talk about the payload. Okay. So at
Perfect,
this
sir.
stage, we think all you need to know is the weight and the power consumption. You are not going to do detailed design at this stage, so that you need the dimension of the UAV.
Okay, sir. Got it. Thank you, sir.
Okay, next.
Sir, I'm from Team Martian Maverick, sir.
Yes.
Sir, I have two questions to ask. Whether we can look for various regeneration method for energy, sir, or else we want to rely upon solar.
See, the problem statement itself says solar UAV, no? So what do you have in mind, for example?
Sir, in Mars, wind speed is a lot more, sir. So can we use another regeneration method to convert the
No,
wind
you are
to kind?
you have been asked to design the solar UAV, so you design a solar UAV.
Okay, sir. Sir, can I know the mission profile? What to be?
Mission profile is given in the problem statement. We want to traverse from the surface of the Mars to 100 meters altitude. We want to do multiple hops. That is a mission.
So maximum range that would be covered will be described, or it is upon our design.
The aim is not to travel distance in Mars. The aim is to travel up and down. Of course, there is nothing like maximum range here.
Okay.
The
Thank you.
important thing is how many hops can you do in one day, because you have sunlight only for a particular duration on Mars. With that sunlight, you have to now charge some onboard source, maybe a battery. So how many times can you travel from zero altitude, that is surface of the Mars, to 100 meters over the Mars atmosphere in a particular day? That is what you maximize, number of hops. Range is not important.
Okay, thank you.
Next question. So now, do you want to add some comments to what I said?
No, sir, I think it's all good. Unless they have any specific questions, we can address them. But I think all evaluations, all the feedback for the IVRs was covered well. And others is, if anyone has any questions, we are happy to answer that.
Okay, so T. Manu has a question. Go ahead.
Good morning, sir. Sir, for the midterm report, we will be covering the tasks which we have to done in which we have to cover in the midterm, like stage two. Plus, do we have to include the stage one task also in the same report, or we should directly start with the stage two only?
No, there is nothing like stage one. The stage one was only to evaluate which teams are serious and which teams actually are doing the work with proper planning. So that is over now. So stage two, the current stage we are in right now, you start the work now. So whatever you have done in the past, that information, if you have already given in the previous report, but you have given a very brief report, now you can give a more detailed one.
Okay, sir. Thank you, sir.
Sir, Pond UAV again.
Yes.
Sir, when it comes to propellers, do we have to select pre-existing propeller airfoils, or do we have to design our own during initial set?
Pre-existing aerofoil profiles may not be suitable for Mars because of the density of the air. If you can find an existing propeller that is suitable, that will be nice. But chances are you will not see, because existing propellers have not been made for Mars. No?
Yes, sir.
Nobody has made propellers for Mars. So why will you get them in the market or in the open literature? Unlikely.
Yes, sir.
Yeah, so there is a suggestion from our coordinator. He says that you should include everything in your stage 2 report, just limited by the number of pages. Whatever work you have done, you should show in that. So Nikhil Verma, you are from which team? Okay, SVT Yan 7, please ask your question.
Sir, for the propulsion system sizing, do we need to name the products that we are going to use, or just about the sizing? And
What do you mean by naming the product?
like, if we are going to incorporate that product or that item in the final system, do we need to name them or not right now?
See, if you not right now, that will be in the final report maybe. Right now, you don't have to go to that detail. Right now, you will be working only on sizing methodology. So you will have what is called as rubber sizing. Later on, when you finalize the design, you will then say, okay, we need so much of thrust finally. So then you will say, okay, there are 3 motors. We will, because you need to know the weight also detail. So then that time we will need, but right now we are not looking. As I said, at this moment, in this particular stage, we are not looking at a final design. We don't expect any final design to be given to us. We expect a very critical study of the various configurations.
Okay, sir. Thank you, sir.
Okay, any other question? What specific, you can tell us later on, what specific topics you would like experts to cover in the next webinar? No need to tell right now. We have a group, and I find that our group is not active at all. You are not using the WhatsApp group to ask your queries or the dedicated email address. Only few people are sending mails once in a while. The best thing is to send the message on the WhatsApp group because everybody gets to know. But if you have some secret or some kind of a, you want to hide it from other teams, then you can send a mail also. Okay, Riot has raised hand. Go ahead.
Sir, we don't have a question, but I wanted to ask, sir, we sent a request for change of team members. So you told that we need to write a formal letter from the faculty advisor. So we did that also, but yet the email is not acknowledged by you, or we didn't
Okay,
receive the reply.
that we will check. So I will request the support team, Prachi, Pranav, to check this, and Norman to check and revert back to you. Okay, so if you have sent a letter signed by the team mentor, I don't think we have any problem in changing the team member.
Thank you, sir.
So you can assume it is done, but we will confirm why the reply has not gone. Maybe it is an oversight. Okay, we have another 10 minutes max.
So this is
Okay,
Rajat
Aero
from
Indians
Team
5.
Mangal.
Okay, 1 minute. 1 minute. Aero Indian 5 has a question on the text. Do we need to provide design or sketch of UAV for midterm report? Yes, whatever work you have done in the till midterm, you have to show us that. It could be a simple sketch of using OpenVSP. No need to go for any CAD modeling at that stage.
Sir,
Okay,
this is from
next,
Team
Team
Mangal.
Mangal, yeah.
Sir, as per instructions given to us guidelines, the report should be as limited number of pages. Could you please let us know the range of the number of pages that we need to concise our report? Numerical
No,
range?
there is no range. It is a fixed number. I think uh, I will
I
have to
mean,
just check. I think the number of pages is 50, and for the midterm report and 100 for the final report. But we will cross check. All that is mentioned in the problem statement in the
yes,
on
sir.
the
I went
website.
through. Yes, sir. The midterm report shall not be more than 50 pages. Yes.
Yeah, yeah,
Thank
and
you,
we
sir.
normally also give guidelines on the report separately. So this information will be available. If it's not there, we will ensure it is there.
It is there, sir. Thank you.
Okay, Prachi has a comment. Mission requirement says waiting period of 100 seconds after each flight after battery recharging. How this is going to affect design? So Prachi, this will ensure that people do not go for what is called as cut-to-cut optimization where there is no margin at all. So therefore, it's like a factor that you have putting it. So between each charging, recharging, there is a 100 seconds gap. So that will affect the size of the solar panel. It will be a little bit larger than what you might require as a margin. Because when people do design, many a times when they want to increase some parameter, they don't keep any margin for many things. So that's why we wanted to keep a margin. That's why we gave this 100-second gap. Okay, any more question anybody has? IIT Martians. Good morning. Is the stowage system same as that of the aeroshell? So the stowage system basically means the method or the scheme to fold the whole system to fit inside the aeroshell. So aeroshell is a part of the rocket that launches this system. And we cannot have, suppose your UAV has a wingspan of 10 meters. We cannot have so much space. So we need to fold the UAV. So that is called as stowage. So when you fold it, we have given you some aeroshell dimensions. So within that aeroshell, it should be foldable and attachable. That is what we are suggesting. SVT on 7, yes, go ahead.
Sir, in the mission requirements, the storage diameter is given. So the height should be the same or it is different?
That is a good question. We have given the diameter, we have not given the height. So this we will confirm from ISRO on what is the height in which the storage has to be put. So this we will revert back to you after confirming.
Okay, sir. Thank you, sir.
Sir, one final question.
Yeah.
Sir, in the problem statement, we have the stowage system mass fraction. So does that refer to the mechanisms that are present in the UAV that help in the stowage, or does it refer to an external structure that would store your UAV into the aeroshell?
Pranav, I want you to answer this question. My feeling is that this is the mass of the items on the UAV which help in storage, like
I
the hinges
concur.
and all that.
That's true. Yes.
So to enable storage to happen, there are certain features or items to be provided on the UAV. It is the mass of those items, like the hinge or any linkages or anything else.
Thank you, sir.
Okay, another 5 minutes remaining. So I have a question which is a non-technical question and which we have been discussing a lot. So our organizing committee members felt that it will be a good idea if we can create some NACDeC t-shirts or NACDeC merchandise like cups, etc., and make it available to the students at a price. So I would like to know how many of you would be interested if we design and get a NACDeC t-shirt made, and then we will ask people to indicate how many pieces they want, and then we will try to ship it to you. Okay, so what you do is if you are interested in the NACDeC t-shirt to be procured and given to you at a cost, you can just give a thumbs up or raise your hand. Because then we will circulate a Google form, ask for the sizes. There are two possible options: round neck and collared. There are different colors. We are in touch with an artist who can probably just draw some interesting art, and with that the t-shirt can be fabricated and ordered. So the round neck t-shirt is a little bit less expensive, about 300, 350 rupees. The one with the collar comes at about 100 rupees more, 450 to 500. We can even conduct a design competition for the t-shirt, and whichever design is found the most suitable by our team, that person gets a free t-shirt. We can do this also. Okay, so there seems to be response from quite a few teams. So we'll look into it. I will leave it to the organizing committee members. Okay. So I think with that, we are going to now stop our meeting and wish you all Merry Xmas and a Happy New Year. And we will again have a webinar after we resume. Sometime after 5th of January, when we resume, we can have another webinar because it will be just about a month and 10 days away from your submission. So we can have one more webinar there. And through the WhatsApp group or the email, you can indicate to us what specific topics need to be covered in the webinar and do it with at least 1 week in advance. By 31st of December, we would like you to send the message so that we can approach the experts and then decide on the seminar. Okay, so some people have raised their hands. I don't know, it's for t-shirt or is it for a question? So let's set him Abhimanyu. Okay, Safira for team t-shirts. Okay. Abhimanyu, is it for t-shirt or for asking a question? Rocket Club IISc. Do you have a question? T-shirt, okay. Great. All right. So we will circulate a Google form and then we will take a call on depending on the number of t-shirts which are provisioned. Okay. And we'll also announce this competition very soon. Okay. So have a nice day, all of you. I'm going to stop the meeting now.